In this question, the first things to notice, so they have given the total length of the edges of the cuboid, and which is 72. So what do you mean by the total length of the edges of the cuboid means? All these four sides. So this is like on the top. Similarly, you will have the four sides in the bottom, at the bottom, and also these four lengths. So 1, 2, 3, and of course, so there will be one more thing. So something like this. So this is what it meant by the total length of the edges of the cuboid. So in that case, if I talk about the base, so this is going to be 2x as well, and this is going to be x as well. So in that case, I can say it's basically 2 times 2x plus 2 times x. So this is going to be the sum of all the edges at the base, and the same thing we have it at the top. So that's why I'll just multiply this one with 2. And if I talk about the edges with the length h, so that is going to be 4. So 4 times h. And this is what is the total length of the edges of a cuboid, which is given as 72. So now we need to think about making h the subject. Why do we need to think about making h the subject? Is if I talk about the volume of a cuboid, so volume of a cuboid is length into breadth into height. So here my length and breadth could be x and 2x, and the height is h. But we want to show that it's completely in terms of x. So that's why we need to figure out what is the value of h in terms of x. So that's why we need to think about making h the subject. Here, when you simplify this, this is 4x plus 2x, which is 6x, and 6x times 2 would be 12x plus 4h equals to 72. So from here, when you think about making h the subject, so it would be 4h equals to 72 minus 12x. So h would be equals to 72 minus 12x divided by 4. And you can also factorize 4 common out in the numerator. So when you take 4 common out in the numerator, it would be 18 minus 3x divided by 4. And 4 and 4 can get cancelled out. So the value of h in terms of x would be just 18 minus 3x. So now this 18 minus 3x we can substitute in place of h. So this is going to be, this is the formula for the volume of a cuboid. So in that case, volume would be equals to x times 2x would be 2x squared. 2x squared times 18 minus 3x. Now, when you expand this one, so this is going to be 2x squared times 18 would be 36x squared minus 2x squared times minus 3x would be minus 6x cubed. So when you compare these two equations, so we have it something like the volume expression, volume of a cuboid to be ax squared minus 6x cubed, and but we got it something like 36x squared minus 6x cubed. So that is the reason the value of a is, when you compare the coefficient of x squared, so it has to be 36. So 36 is the right answer for this one. So now, in order to solve part B, find the value of x which makes the volume to be maximum. So which is, we call it as a maximum volume. So 36x squared minus 6x cubed is the equation. So now there are two ways. One is either we can use the concept of calculus to solve this, or we can think about using the graphic calculator and do it. So I'm going to use the calculator and solve this. So in order to solve it using the calculator, I need to think about drawing the graph. So when I plot this, this is 36x squared. This is TIN square calculator. So 36x squared minus 6x cubed. When I plot this graph, this is going to look something like this. I need to think about zooming out. Otherwise, let me change the y coordinate. Let me change the y coordinate. The y coordinate seems to be very, very large here. So let me change the y coordinate to be 200 here and see what's happening. Yes, I'm able to see some maximum points. So let me change this to more. Let's say instead of 200, let me change it to 300. I'm able to see the maximum point very clearly. So let me change these values. So this value, I'm going to change it to be x to be from, let's say, -10. And to +10. So I can clearly see it. So this is what, so whenever you have any graph, something like this, so this particular point, we call it as a minimum point, and this is, we call it as a maximum point. To be more specific, we also call it as relative minima and relative maxima, or a local minima or local maxima. So we need to figure out what is this point is. So in order to do that, so we will be doing this one. So we have to go to menu, then analyze graph. So there is a maximum. So we need to check we need to fix the lower and the upper limit. So the lower limit is here and the upper limit is here. So I can clearly see this 4,192 is the maximum point. So that means when the x coordinate is 4, the volume is going to be 192. So that is the maximum volume. But in this question, they are asking you find the x value that makes the volume maximum. So that x value is 4. So we are talking about in centimeter. So when x is 4 centimeter, whatever the volume we will be getting it of this cuboid, that will be maximum. So x equals to 4 is the right answer for this sum.